Transportation Studies. I want to welcome everyone here today to our weekly transportation seminar. I will remind people that we do webcast the seminar, and so if you are going to ask a question of the speaker at the end, we ask you to use these microphones that are in front of you. Keep the red light lit while you ask the question. Some of the microphones do not work. We're working on getting those fixed. I apologize. So if the red light doesn't light up, if there's one behind you could use, try that. So do your best. Anyway, so without further ado, I'm going to introduce our speaker. And I will also note that today's speaker is being sponsored by OTREC, the Oregon Transportation Research and Education Consortium, the Visiting Scholar Program of OTREC, because we're very happy today to have visiting us all the way from Australia via Florida and Orange County and a few other places on a worldwide tour, I'll say. We have Professor Peter Stopher. He's a professor in transport planning at the Institute of Transport and Logistics Studies at the University of Sydney. And he has more than 40 years of experience as an educator and consultant in transportation planning, published many papers and books on transport-related topics, currently working on a book on survey design and management, and is well known on this topic. And today he's going to be talking about using GPS in panel surveys. With that,
thank you. First of all, I think I should probably maybe apologize in advance. I think I have too many slides on this presentation to be able to get through them all in the time that we have, so I may take the liberty of skipping a few rather quickly at certain points. But if in the questioning you want to come back to some of those, we can certainly do so. Let me just indicate, first of all, going too fast. What I'm going to try to do in the next hour or so is to give you a little bit of an idea of what sort of things I'm interested in relation to GPS, then give you a summary of some recent projects that we've been running at the Institute of Transport and Logistics Studies, talk about our survey procedures with GPS, and give you an idea of some of the results of our GPS data collection, and also talk about something that we are specifically able to find using GPS over multiple days, which is looking at variability of travel behavior over a period of time, and then draw some conclusions from that. Briefly, global positioning systems or devices were first used in travel behavior research in about 1995, when the US federal government commissioned a proof of concept project to see whether or not we could actually use GPS to measure people's travel. The initial devices that were used at that time were vehicle-based. They were not portable. They had to stay in the vehicle. Actually, drivers had quite a complex set of instructions as to how to fit these into their vehicle. And it wasn't until probably around 1999 that the first portable or wearable devices actually emerged. Since that time, GPS devices have become increasingly sophisticated and have become more and more available as personal tracking devices. Some of our most recent uses of GPS in Australia have been for evaluating TravelSmart projects. I think that in Portland you've heard something about TravelSmart. It's been introduced in a number of different cities in Australia, and using GPS as a method for evaluating the sort of travel behavior changes that take place seemed to us to be a very appropriate fit, and so that's something that we've been working on. We've also, in common with a number of people here in the United States, have been using GPS to validate and analyze traditional household travel surveys. We've actually been developing GPS for about the past 6 years at ITLS. Part of this has been a matter of refining the survey procedures for use with GPS devices. Part of it has been a matter of developing software to process the results. I understand that some of you are using GPS now on some projects here, and probably one of the things that you will quickly relate to is that you collect an enormous amount of data very quickly. And one of the challenges is how do you process this and make sense out of it? And now, more and more, we are exploring the potential to replace conventional travel diaries with GPS. And I'll talk a little bit more about that later on. We've actually conducted quite a number of projects with GPS recently, and I'd like to just mention a few of those. One of the earliest ones that we undertook beginning in 2001 was a validation of the Sydney Continuous Household Travel Survey. If any of you are at all aware of what Sydney does with its household travel survey, for about 11 years now, they've been doing a continuous household travel survey in which they actually interview about 3,000 households a year. It's different households each year, so they're actually just rolling through the population over a period of time. For doing this validation, which began in 2001, we were really only beginning to have some portable devices, so mainly we used in-vehicle devices, but we did use a few of the portable devices that we were able to acquire early in 2001. In this particular project, the households were recruited by door knocking, which is the procedure that's used in the Sydney Household Travel Survey, and households were only recruited into the GPS part of the survey after they had agreed to participate in the Sydney Household Travel Survey. They were then asked to carry the GPS devices or use them in their cars for 3 to 4 days following the time when they were recruited, and that 3 to 4 days included the one day that they were supposed to do their travel survey for the Sydney Household Travel Survey, and we analysed just that one day to try to determine how well people actually reported their own travel. Then the first GPS project that we had evaluating TravelSmart was a pilot test in Canberra called Households on the Move. The idea here was to try to introduce households to TravelSmart when they were actually moving house. The idea behind this was that people would actually find it easier, perhaps, to make adjustments to the way in which they traveled when they were already moving to a new location and had to work out things about the transport system. I won't say anything more about the TravelSmart intervention itself. There are a couple of papers that you can find on this topic, including one that was published in a transportation research record not too long ago. We use the same mix of GPS devices in this project as in the previous one, that is mainly in-vehicle devices with some portable ones. Again, households were recruited by door knocking, and in this case, households were asked to participate in 2 waves of a panel, where the panel was set up as really our before survey and then a repeat measurement of the same households in the after survey. We recruited both households that agreed to participate in TravelSmart and ones that did not, with the idea being that the ones that did not would provide our control group to see what behavior would have been without TravelSmart. And in both waves, participants were asked to carry devices for a week. More recently, we were commissioned to evaluate another TravelSmart intervention called Households in the West in Adelaide. And this is using a newer portable device for all participants. No in-vehicle devices are being used in this study. We have set up for this one a panel of 200 households which were recruited by telephone, and panel members were then asked to carry a GPS device for 7 days once each year for 3 years. Only households that were willing to agree to do this for 3 years were recruited into the panel. So they were told up front that this was going to be a 3-year study and that they'd be asked to do this 3 times. We've also, contemporaneously with that project, been working on a long-range monitoring for travel behavior change. This has really been sparked by an effort by the Australian government to try to find out whether or not TravelSmart really can contribute to the reduction in greenhouse gas emissions. It's primarily being funded, or has been funded, by the Australian Greenhouse Office, and they asked us to design a method to monitor travel behavior change. the interesting thing here is that you're actually, if you're monitoring households that already were introduced to TravelSmart, say 2 or 3 years ago, then you're actually trying to monitor whether or not their travel behavior is static, no change, whether they're still declining the amount that they use their cars, or whether they're increasing, but increasing at a slower or faster rate than the rest of the population. So it's a little bit of a complex idea for measurement. Again here, we felt that GPS offered a very good possible method for measuring this, and so we have been doing a pilot survey to research some questions about GPS feasibility for such a study. For the pilot study, we recruited a panel of 50 households. They were recruited by telephone, similar to the ones in Adelaide. In fact, they also came from Adelaide. And panel members in this case were asked to carry a GPS device for 28 days in 2 waves. And the 2 waves were 6 months apart. And panel members were then asked to carry GPS devices for 15 days in a 3rd wave, which we have just recently finished conducting. We are also now just embarking on a brand new project, which is to do a validation of the new household travel survey that's being started in Victoria, in Australia. In this case, Victoria, like Sydney, was doing a continuous household travel survey for a number of years, and then changed to doing, they stopped that survey, and then they decided to start again this year, and their new survey is called Vista 07. It has no relation to the newest Microsoft product, I hasten to add. Households in this survey will be recruited by door knocking, and similar to the project that we did in Sydney, they will be asked to carry a GPS device after they've agreed to participate in the household travel survey. In this case, they will be asked to carry the GPS device for a full week, and that week will include the diary day of Vista 07, so that we will then be able to look at the results from that and determine how well Vista 07 is actually measuring travel behavior. And then last of all, we are expecting that we are going to be asked to do the long-term monitoring for which we did the pilot surveys. This is going to be a 5-year project running from the end of this year until early in 2013. We expect at this point that households will be recruited by telephone, and we are expecting again to recruit a panel of about 200 households, for which participants will be asked to carry GPS devices for 15 days once a year for 6 annual waves. So that's a little sketch of the recent, current, and future projects that we have running on GPS. Now, some of the advantages of GPS I'd like to talk about for a moment. First of all, it's a very passive method. It doesn't require very much effort from a respondent. In fact, and it provides a wealth of information. We get very accurate data about the routes that people use, something that we've never been able to obtain from any self-report survey. We get very accurate information about distance traveled, the time taken, and when and where the trip takes place. As you may be familiar, if you've looked at some of the results that have been obtained in this country in comparing GPS surveys with a self-report household travel survey, you'll know that people apparently forget to tell us about something like 20% and more of the trips that they make. They often get the time they made the trips wrong. They also get the travel times wrong and the distances wrong. So GPS clearly provides us with very superior accuracy compared to self-report surveys. We can also get multi-day travel data because it's such a low burden to carry the GPS device around that it's not difficult to ask people to carry the device for a number of days. The newest devices that we're using actually permit the collection of data in all modes of travel. And I should point out here that in Sydney, for example, we have quite a challenge in that we have a train system that's double-decker trains. We also have ferries that have 3 decks. And we want to be able to track people on all of these. Some of our early devices could not pick up people traveling on a ferry and couldn't pick them up when they were in a train. Our newest devices do well on both. We also can get walk and bicycle travel. And we'll talk a little bit more later on about the sensitivity of these devices. There's also a lot of additional things that you can use with the data for once you have collected this sort of data. For example, you can look at things like travel speed by time of day and route. You can look at things like drive cycle behavior and perhaps improve your estimates of emissions. And we can also measure physical activity and health. And of course, with the increasing concerns about obesity and travel, this is a potentially very fruitful area of the use of GPS. I thought this was rather interesting to show you the evolution of the devices, the portable devices. When I talked about some of the very early stuff that we were doing, I was talking about this sort of a device here. That's quite large. And the GPS antenna, which is about the size of a computer mouse and weighs about 3 times as much, is actually fixed onto a shoulder strap of this bag so that you put the bag over your shoulder and the antenna sits on your shoulder and receives the signal, and everything. This bag here contains a big battery pack to run it and a data logging unit. Now the second device that actually was developed under our specifications is this one here, and that's the one that we have been using in both of the recent projects that I talked about, the ones that started in 2005. And our newest device is this one here. And I've got a cell phone there to give you an idea of size, but I actually happen to have one of the latest device with me, which is this one here. It's very small. I'll talk a little bit more about these devices. But the one that we've been using in South Australia is this one. And this has also been used in the long-term pilots. I didn't bring this one with me as well because this has now become our second generation and now rapidly becoming obsolete GPS device. But this one is quite interesting. It's about the same size as a cell phone. It weighs about 110 grams, which is about the same weight as a cell phone. It has 8 megabytes of memory, which we found to be sufficient for about a month of data collection when we're collecting second-by-second position information. It has a powerful antenna receiver which is capable of receiving signals in trains and buses, inside a handbag or in a pocket, in the glove box of a car, inside a house, and in most shopping centres. It contains its own battery within that little box, 110 grams. However, we found that one of its biggest issues has been battery life and power management. The current battery life of that device is only about 8 hours, and that's achieved only using a power management system that involves the device sleeping if there is no movement detected for 2 minutes, which is determined by looking at the GPS position data, and then it wakes up every 3 minutes to check to see if it's moving or not. But that means that, unfortunately, if it were to go to sleep just before you set off moving, it could be 5 minutes before it would wake up and say, oh, I'm moving. I need to start registering position again. So that can miss not only the start of a trip, actually, but it can miss a whole trip, because there are quite a lot of trips that people undertake that are less than 5 minutes in duration. However, notwithstanding that, just to show you the accuracy, what I have on this map here is actually the results of using the first generation device, that one in the daggy bag, and the second device. The second device is the one shown with the red dots, and the first device is the one shown in the sort of yellowy color here. And you'll notice that at times, depending on what we were doing, and these describe to us what was actually happening, where the device was at the time. But here, for example, on the back seat of a car, both devices did pretty well at recording position. In the bottom of a bag, on the floor of a car in the back, the the new device did a good job, the old device didn't do a very good job. Along here, it's on the railway line, and it was in a jacket pocket, and the old device didn't pick up anything at all, but the new device picked up the position pretty well as the person went by train. And we've got a lot of charts like this that show a comparison of the sensitivity of the devices. Now, our newest device is this one, which is the one I have here on the desk in the front. As you can see, it's even smaller. It also has 8 megabytes of memory. It has an Atmel GPS chipset, which is about the same sensitivity as the Surfstar 3 chipset, which is one of the newest and most sensitive chipsets that's come out for GPS. It has a much longer battery life. We actually have, well, we claim that it's up to 4 days, but actually what I really should say is that after using it for 4 days without charging, it still hadn't run out of battery power. So we think it may, we don't actually know what battery life is, but it seems to be longer than 4 days. It has a faster signal acquisition than the second generation. It's smaller and lighter weight. It only weighs 50 grams. It runs off a common battery that you can find for a cell phone, as you might be able to see in the back here. It's just a very common cell phone battery. The really neat thing about this is it has a vibration sensor in it, and this is what it uses for power management. And the vibration sensor is set so that if there is no vibration detected for a period of time that the user is able to specify, for example 5 minutes, 3 minutes, 10 minutes, then the device turns itself off. But the moment that there is vibration detected, the device turns on and starts searching for a signal. I'm not sure if you'll be able to hear it from where you are, but I will turn this on and see it actually talks to you.
Satellite's positioning.
So right now it's saying that it's trying to position itself. Now, if we were not in a multi-story building like we are, in about 30 seconds or so, it would find its position, and then it would say, satellite's fixed. So it'll tell you when it's actually got a position fixed. Another thing that it does is it will also tell you if the battery power is getting low, which is a very nice feature in it. It also has display lights that show its status. At the moment, it's actually flashing a green light, which you might be able to see, which simply indicates that it's on. Once it has position, it will alternately flash green, red, and yellow. It also has Bluetooth communication capabilities, which I can turn on, although the Bluetooth simply allows it to transmit its position to any nearby Bluetooth device that is set to receive its information. So it receives it in real time, but it can't actually be used to obtain the stored data that are in the device. Now, those 2 early wearable devices that I showed you cost us over 1,000 Australian dollars. The Australian dollar today is worth something around 83 or 84 US cents. So it's not a lot less in US dollars than it is in Australian dollars. But these newest devices, I'm actually paying less than 200 Australian dollars each for these. So they've come down enormously in price. As the size has reduced and as the sensitivity has improved and the capabilities have improved, so the price has come down. And of course, we can use these many times over, so the capital costs that we're incurring in buying these devices can be spread over many uses. With the current memory that this device has, it is more than sufficient to obtain information on all the travel that most participants would do over a period of at least 2 months. If you have somebody who actually travels for a living, such as a mailman or a plumber or somebody like that, you might run out of memory in 2 months. But for most of us normal human beings, you won't run out of memory. Now, what's the procedure that we use for getting people to undertake the survey? Well, it's a procedure in which we provide, first of all, a pre-notification letter where we tell people about the study, what its purposes are, and so forth. We then use either, as you have seen in our recent projects, telephone or face-to-face recruitment. If we use the telephone, then the devices are usually couriered to the household. If we use face-to-face recruitment, then the devices are actually handed to the household members at the time of recruitment. We collect demographic, address, and vehicle data from the households. Because of the requirements of the University of Sydney and our ethics committee, we actually have to have participants sign a consent form to participate in the survey. We also provide instructions and frequently asked questions, and something that we introduced only quite recently is a card to indicate, for people to indicate days on which they do not travel at all, or days that they also forget to take the device with them. This is rather important because when you're collecting multiple days of data with a device like this, if you have a day where there is no information showing up, you don't know whether the reason for that was that the person stayed home all day, or the reason is that they forgot it or intentionally left it at home. In our experience, people actually very rarely intentionally leave it at home. And on the card that we created, it has a number of different things that people can tell us about the device, such as that they did not travel on a particular day. And the one about forgetting it says, "Oops, I forgot to take it with me." And the oops actually works very well. It seems to make people not at all uncomfortable about reporting that they forgot it. And so we are actually getting very good information about when that is forgotten. That form is returned with the devices. Just to give you a very quick look at these, this is the vehicle information form that we use. It collects information about each of the vehicles in the household. And this is the household information form. The important thing on the household information form, which is a little bit different from what you might do in many surveys, is that to aid us in our subsequent analysis, we ask people to tell us the address of each workplace, the address of each educational establishment used by members of the household, and over here we ask them to give us the location of the two grocery stores that they use most frequently. All of the address information we then geocode, and this is used to help us analyze the data from the GPS. Here's the rest of the household information form, which provides data about each person in the household. Also importantly tells us whether or not, let me see if I can use the mouse to point it out. Up at the top here is a question about whether or not the household owns any bicycles and how many. That's very important for us in analyzing the data subsequently so that we can determine what modes of transport were being used. Here's the form I was talking about that we have people fill out to tell us about what happened with using the GPS. As you see here, it says, "I didn't go out all day at all today. Oops, I forgot to take my device with me today. I took the device with me for some of the day, and yes, I took my device with me all day." And so they simply check for each day of the survey how long or what the status of the GPS was, and also because of the problems that we had with the second generation device, we asked them to report at what time the battery ran out in case we lost their records partway through the day. So we retrieve the devices and the forms by courier if it was a telephone recruitment, and if it's face-to-face, the interviewer returns to the home to pick up the device and the forms, and only in the event that nobody is at home at the appointed time does the interviewer then leave a courier label so that the devices can be returned by courier. We give a telephone reminder to households on the day of courier delivery and the day before courier pickup. And in the subsequent waves of the survey, forms are pre-filled with the information that people provided the last time, such as here, where you'll see in this part of the form, this is all the information that they provided us before about their cars, and then there is space here to add any new cars that they might have acquired, and also there's a place there for them to tell us if they've sold any of those cars. And similarly, on the household information form, we play back to them the information that they gave us before, and then they can provide new information here about a new member of the household, plus they can tell us any changes that have occurred to anybody's status. A common question that I get asked at this point usually is, how many devices have you lost that people didn't return? Well, so far we've lost 4 devices, but 3 of them were lost by the courier. Only 1 of them was lost by a household. And that was really probably our fault. It was actually a device that was sent to a household by courier, and we authorized the courier, if they could not get an answer, to simply leave the package at the door. And this household, after repeated attempts to contact them, were never ever able to be contacted. We actually sent people to the address to look for the package to see if it was still there. They could never find it. So somehow the device disappeared. We've no idea where it went. But that's the only instance where we've actually lost a device to a household. And the other 3 devices, the courier company claims they returned them to us, but they actually never delivered them. And there's no signature to prove that they were delivered. And those are the only losses we've had. Because actually, the devices are not much use to anybody. They don't display anything. There's really nothing, and there's no way that they can get the data out of them. So they're really not much use. And so despite their value, we've had no problems with losses. What do respondents have to do? Well, they have to turn the device on. They have to recharge the device whenever possible and carry the device with them whenever they leave the home. One of the things we found is very easy, and we will be putting that on this device shortly, is if we attach a key ring to the device. And it can then very easily be put on the person's key ring. Then it goes with them wherever their keys go. And in our experience, people very rarely leave their keys someplace when they go traveling. So if you pick up your keys and take them with you, and your device is on your key ring, it automatically goes with you. And that happens actually to be a very good position when you have a key in the ignition of a car. It leaves the device hanging vertically, which is actually a very good position for it to receive a signal. But otherwise, if it ends up in somebody's pocket or in a bag, a purse, a backpack even, with even the second generation device, it picks up signal extremely well in those locations. We've held some focus groups in Adelaide with respondents who undertook the GPS survey, and we actually had 4 focus groups. One group was a group of people who had been asked to do a 7-day GPS task and had done it well. The second group was a group of people who were asked to do the 28-day task and had done it well. And then the other 2 groups were the 7 and 28-day groups who had done a very poor job. Most of them had given up in the first day or 2. And so we held these focus groups to find out what people thought about doing this. And actually, all 4 groups said that it was a very easy task. They also found the household and vehicle forms that we were using very easy to fill out. And we got a very interesting response, actually, about the length of time that people would like to carry the devices. Those who'd been carrying them for 7 days said, by the time we got to the end of 7 days, we'd really figured out what to do with this. And we wished you'd asked us to carry it longer. And we'd actually like to have carried it for about 2 weeks. And the people who took it for 28 days said, well, 28 days got a bit long. If you'd asked us to do it for 2 weeks, we'd have been much happier. And so 2 weeks sounds as though this is about ideal. And as you'll see a bit later on, we've actually found some other reasons why 2 weeks looks as though it's actually an ideal period of time to collect the data. So far as our response rates have been concerned, I should point out here that generally we've done this by using a random sample of addresses against which we have then done a phone match and included only those households that we can phone match. We then posted out a pre-notification letter, did a telephone recruitment, and then couriered devices and survey forms to the recruited respondents and picked up by courier. In all cases, this was for a panel where households were told up front that they would be expected to do this 2 or more times. And with this method, we've had a response rate that has been very similar to conventional surveys using this type of recruitment method in Australia of about 30%. But this has been for a panel survey and 1 week of GPS use or 28 days of GPS use. And we would expect that if we had only been trying to do this as a one-time survey, the response would have been quite a bit higher. We've actually never tried to do this for a one-time survey, so we don't have a direct comparison to a typical household travel survey. We've also done quite a lot of analysis of demographics of the households and have found relatively little evidence of significant bias in the households that we have been able to recruit into the sample. Both the 50 household sample that we've been using in South Australia and the larger 200 household sample show quite good correspondence to census statistics. And we do a census in Australia every 5 years, and our last one was done in 2001, for which we have data. And comparing against that, we find only some very minor differences. The Sydney Household Travel Survey Validation Study did show some biases, but this was a very different type of study with a different recruitment procedure. Here's an example of some of the results. What you will see here is that in all 3 of the GPS surveys, which are the last 3 columns that I have on the slide there, the average household size is a little bit higher in our GPS survey than the 2001 census shows, which is an interesting result because usually in household travel surveys we have a bias against large households, which means that our average household size is often too low. Average number of vehicles is also a little bit higher. Average number of adults, because of the larger household sizes, is slightly higher, not very much. The proportion of the population who are adults is actually a little bit lower, which is an interesting result. Average number of children, though, is fairly high. Proportion of the population that are children is a bit higher. The average numbers of males and females, as you would expect, given that we have slightly larger household sizes, are each a little bit higher. The full-time workers are higher, but here you have to figure out that in 2001 we had a rather high unemployment rate in South Australia, which is much lower in 2005-2006. So we would expect more full-time workers. We also have a higher number of average full-time students. But overall, most of those differences were not statistically significant, even though you see numerical differences. You have to remember that 2 of those columns were for a very small sample of only 50 households, and you're going to get some differences with a small sample like that. There are some disadvantages of GPS surveys. Perhaps the worst ones are signal loss and degradation that may occur during the use. The devices also may take time to acquire position, which we call cold start. It's not the same as the cold start for emissions purposes, but we have a cold start problem that we often don't get at the beginning of a trip. Devices can easily be left at home, or the respondent can forget to charge them. The processing requirements definitely are extensive. And one of the things that I have to say at this point is that although we have come up with ways to deal with a lot of different things with the GPS, we haven't yet come up with a way to determine who is a passenger in a car and who's the driver. The processing that we run, and for which we've developed some extensive software, allows us to correct some of the errors in GPS and also makes the data more useful. We have multiple procedures that are included in our software. This includes the identification of trips, repair of cold start and canyon or tunnel problems, And also, we now have software that identifies the mode of travel, and we're just putting the finishing touches to software that identifies the purpose of travel. This shows something about canyon problems, and this was a comparison we did when we got our second generation device. The first generation device shows the blue dots here, and you can see little bits of blue and not very much there. And the red is the second generation device, and this is going right through downtown Sydney, which is a major canyon area. And as you can see, the first generation device pretty much failed to pick up position for almost that entire trip. And the new device, on the other hand, got position all the way through. Now, I will certainly acknowledge very quickly here that we don't have an urban canyon like you would have in Manhattan. But we've got some pretty high buildings in downtown Sydney with some very narrow streets. And yet, with repeated experiments of going through downtown Sydney, we don't find we're running into problems. We also, before we do the mode and purpose identification, we do a visual check of the results from the trip identification. What we have found is that our trip identification software now seems to be about 95% accurate. We miss a few trip ends that are very short. For example, somebody dropping off a person or picking up a person, stopping to mail a letter. Stops like that we generally can't pick up. We also do identify a few stops that are not real, that are not actually destinations. These would be traffic stops that are very long. But for the most part, we're getting about 95% accuracy, and by the time we've done our visual checks, this improves to probably around 97, 98% accuracy. We've also used the visual checking procedure to continually modify our software so that it's doing an increasingly better job at identifying problems. Our next step, by the way, we're at the moment using software that's based entirely on heuristics. Our next step is to try to introduce fuzzy logic into this. We haven't done that yet, but we are planning on working on that. Here's an example of the sort of output that we get after we've gone through all of the checks and procedures. And here you can see that we've identified actually the trip purposes, and you'll see on the next slide some information on the modes of travel as well. We've also projected everything onto the actual street network, and so we know the actual route used. Here's a better example still, and we've got a little table down at the bottom here that shows the trip purpose, the mode of travel that's used, and then things like the departure time of each trip, the travel time, and the distance covered. And these stops would also be identified on the map as to the actual locations that they represent. Using our small 50 household sample that carried devices for up to 28 days, we've been looking at variability of day-to-day travel. And we've excluded a number of the people in our sample here when we have what we consider to be relatively poor data from the household. We ended up with 44 people that gave us 21 days of good data, and if we restricted the analysis to just 15 days of data, we increased our sample size to 65. We analyzed 5 different attributes of travel: person kilometers of travel per day, the number of trips per day, the travel time per person per day, and the average travel time per trip and the average travel distance per trip. We have not at this stage analyzed mode and purpose. I'm going to present to you some graphs rather quickly that show the 20-day and 15-day data, and what I'm looking at here is what happens to the means and variances. And before I show you some of these graphs, I'd just like to point out that these are cumulative graphs. What I'm going to be showing you, well, in fact, let me put the first one up and I can explain here. Where you see day 1, this is simply taking the mean from all the first day of data collection of every person. 2 means it's the average of days 1 and 2. 3 is the average of the first 3 days. So that when we get up to 21, this is the average from all 21 days. And what you see here, rather interestingly, not very clearly on this one, but what you do see is that there's quite a bit of variability at the beginning of the data, and then it seems to settle down to a fairly consistent value somewhere out around about 12 or 13 days, and it's a lower value than the value you get looking at 1 day. Now that gets to be a little bit more clear when we look at some of the other variables like mean trips per day, and also in the mean travel time per day. And now, even more interestingly, this is what happens to the variance. The variance starts very high in both cases with 1 day of travel, and now it declines very rapidly over the first few days and then levels out somewhere around about day 12. I found that result particularly intriguing because what it suggests is, when we build models, travel demand models, we're trying to explain variance. Now, what this would tend to suggest is that the actual variance in travel, when we look at it over multiple days, is perhaps only about 1/3 of what we see when we take a snapshot on 1 day. So when we look at our models and we say, well, we've got this big unexplained variance, maybe a lot of that unexplained variance is variability that we shouldn't actually be trying to measure in the models or capture in the models, because it's actually a construct of simply taking a 1 day snapshot of people's travel. And we find that this pattern, while perhaps not quite as dramatic on the other ones, does continue to appear for each of the other attributes that we looked at. In each case, the variance drops after the first few days and then levels out to a value that, in this case, for example, on number of trips per day, is a value of about 12 compared to 18 from 1 day data. So it's about 2/3 of the variance. Variance in travel time per trip is a little bit less understandable here. Again, though, it varies a lot in the first few days and then levels out. And here what I've done is to separate out, because one of the things you might have thought about on the previous slides is, well, what if the thing that we're looking at here is the effect of weekend days, because of the fact that we're measuring over all days of the week. So in this case, weekdays are in the pink and all days are in the blue. And what you can see here is that the variation in the variance is actually not a lot different between the weekdays and all days. And the same here, travel distance per day. Again, actually the weekdays seem to be more variable to start off with than all days, and yet they converge to a slightly lower figure in the final variance. So all of the means and variances seem to exhibit similar patterns, which is that for the first few days there are substantial changes, after which there is usually a slow and steady decline that levels off for most variables. The implication from this is that 1 day and 2 day surveys may be seriously overestimating most of the statistics. And the variance tends to be highest at the outset and then declines, except for the case of number of trips. Now, we thought, well, maybe this is a halo effect. Maybe what's happening here is that people are traveling differently for the first few days they've got the GPS device. So what we decided to do here was to compare days 1 to 12, which are in the blue, with days 4 to 15, which is in the pink. Same number of days, but we've thrown out the first 3 days on the assumption that the first 3 days might have been affected by the fact that we were asking people to carry GPS devices. And what you see here is that actually the variability or the changes in the mean are more dramatic for the 4 to 15 days than they are for 1 to 12. And we did this repeatedly. I don't have time to show you all the different charts that we have, but we did this for all of the variables, for both the means and the variances, and we found, again, the same thing here, that generally the variability that we were finding was as great, if not greater, on days 4 to 15 than it was for 1 to 12, which tends to suggest that there are no halo effects. So ignoring the first 3 days didn't reduce the differences, it increased them. Stability still seems to occur after about 12 days of measurement, and the earlier variability, we conclude, is not a function of the halo effects of carrying the devices. Now, one other thing that I think is quite interesting is to look at intrapersonal variability. That is, how much do people's behaviors change from day to day? Rather interestingly here, for some recent research that I've been doing, I've been corresponding with a researcher here in the US who had not seen anything much in multi-day data, but suggested that perhaps the intrapersonal variability might be about 50% of interpersonal variability. Well, we found that that is not true. In fact, what we've tended to find is that intrapersonal variability is about 3 to 5 times as big as interpersonal. And you can see this in some of these charts. What we're looking at here is what percentage of the total sum of squares of each of these measures, number of trips per day, travel time per day, travel distance per day, is attributable to intrapersonal variability. And we varied this by looking at only weekdays of week 1 in the pale blue, yellow is only weekdays of weeks 1 and 2, then red is all days of week 1, and blue is all days of weeks 1 and 2. And what you see here is that on, for example, number of trips per day, when we look at only weekdays of week 1, the intrapersonal variability accounts for nearly 60% of all of the variability. When we look at it over 2 weeks, it jumps to over 70. And it's even larger when we look at all days. When we look at travel time per day, for just 1 week, with only weekdays, it's only a little bit over 40%. But when we add 2 weeks together, it jumps back up to nearly 70%. And travel distance per day shows a very similar pattern. So this shows that over a couple of weeks, and again suggests that 2 weeks might be a good period over which to measure behavior, intrapersonal variability is accounting for a lot of the total variability. I have some additional charts here. This one shows the same sort of thing now for all days of week 1, all days of weeks 1 and 2, and all days of weeks 1, 2, and 3. Now what you notice here is there's quite a big jump from 1 week to 2 weeks, but a very small increase when you go to 3, which again is reflected in each one of these and suggests that that third week of data isn't actually telling us much more than what we got out of 2 weeks. And here we looked at the variability by day of week, and as you might expect on most of these variables, the greatest intrapersonal variability occurs on the weekends, except, very interestingly, number of trips per day on a Monday, which for some reason has almost the highest intrapersonal variability component. But for the rest, this is the weekend, the orange and the dark blue, orange and dark blue, orange and dark blue, and the weekends tend to be much higher than during the week, which is you would expect, because during the week a lot of us have to go to work every day or go to school or other things of that type, and so we're much more regular in our behavior and much more different on the weekends. Overall, we found that intrapersonal variability accounts for as much as 76% of the variability for the entire data set. It drops to only 64 to 71% if we look at only weekdays, and if we only look at 1 week of data, it drops to about 40 to 60%, depending on which measure we're looking at. It increases with more weeks of observation. It's lower on weekdays than on weekend days. except for the number of trips per day where the variability is highest on Monday and it's relatively low on the weekend. So overall, GPS measurement captures much more information than 1 or 2 day diaries. The importance of the information captured may have some large impacts on modeling. We haven't actually got to the point yet of trying to use any of these data for modeling purposes, and I'm rather looking forward to the point when we can do this, because I'm expecting that we're going to see some very different results when we start using this for modeling. But the modeling implications of multi-day data need to be researched, and they may be quite far-reaching on model quality. And there's a possibility that significant amounts of unexplained variance are actually a result of the methodology of measurement that we've always used in the past, not people's actual travel behavior. I just threw in a few additional slides here to show you some other things that you can do with GPS data, such as looking at travel times and speeds. And here on this trip, we've actually color-coded the dots according to the current speed. And the greener the color, the faster that the person is traveling, and the more red the color, the slower they're traveling. So you can very easily pick up where congestion is occurring just by looking at the speed profile. Here's an example of drive cycle analysis, and actually this is 2 different drivers driving roughly the same route. And you can see that the top one in the blue is actually a fairly conservative driver, and the bottom one in the red is a very aggressive driver who's continually accelerating and braking. They're both driving the same route at the same time. Again, interesting information about the emissions implications of their driving. We've also picked up bicycle travel, and everything that you see on here is actually bicycle travel, and again is color-coded by speed so that we can pick up the speed of the bicycle. And this one shows some multimode travel. You might wonder what somebody's doing out here, but this is actually a ferry trip. We have a lot of ferries in Sydney because we have a lot of water, and it's very useful that we are actually able to pick up their movements over water as well as in a train and walking, and the only place that we lost them here is actually in a tunnel which the train goes into under downtown, and then they re-emerge out here. A few last points that I will make, and then I will wrap this up. Conventional wisdom has suggested that we need generally at least 1,500 to 3,500 households in a survey for modeling purposes. What that generally produces is around 3,750 to 9,000 person days of travel. Assuming that this is the requirement in person days of travel for modeling purposes, GPS could produce the same amount of person days of travel from as few as 240 households doing the task for 15 days to give us 9,000 person days, the upper end of that, or as few as 100 households for 15 days to give us the 3,750 person days. Now, I want to caution here for a moment that you can't do a direct translation of the numbers here, because one of the things that we've got in multi-day data is a lack of independence between the observations. And when we draw a normal random sample and use it for modeling, we're assuming that each person that we observe is independent of the other people. Actually, that's not even true generally of the data we collect, because we collect data by households, and people within a household are usually not independent of one another, but we treat them as though they are. But clearly when we get into multi-day data, we should not treat each observation as being independent. I'm actually at work at the moment on trying to determine what are the sample size requirements from a GPS. But the results that I'm coming up with at the moment are that they are much, much smaller than those of a conventional household travel survey. Also, when we look at modeling, we may find that the sample sizes go down again because we remove irrelevant and extraneous variance. We're also removing reporting error. We may have to increase our sample sizes for political and other reasons, in that we may be talking about such small samples that the politicians who are going to use the results from this may not be willing to believe our results from so few households. So we may actually have to increase the size of the sample significantly above what is required statistically in order to be politically acceptable. I suggest here, for example, that maybe we need 600 to 750 households with 15 days of travel as a political sample, which that will produce a huge data set of somewhere between probably 22 and 30,000 person days of travel, which for the modelers among you, I suspect you would say that would be hog heaven so far as modeling is concerned. Based on our focus group experiences, we think that the best method of recruitment would be door-knocking recruitment, providing in-home instructions on the device use. And we've also introduced, which I didn't talk about, the collection of odometer readings both at the beginning and end of the GPS period, so that we have a further check on the actual VKT that we measure. The devices could then be picked up by the interviewer or by courier together with a final odometer reading at the end of the period. That method needs to be pilot tested. We haven't actually used precisely that method for just a GPS survey, but we believe it would have many benefits. The cost per person day of data will then turn out to be very much smaller than that of conventional surveys. The data quality is much higher. And we also need to test a method to determine the use of car passenger by non-family members, because that's about the only thing that we are not able currently to obtain. So I don't want to leave you with the impression that I think that GPS is a foolproof method. It is not. It is not 100% accurate. When we do our analysis to identify mode and purpose, we believe that we are getting about 90 to 95% accuracy on the identification of mode and purpose. And as I've already mentioned, we get about 95 to 97% accuracy on identifying trips. All of those are much higher than we get from self-report data. I think that GPS offers huge advantages over conventional surveys, and the quality and the nature of the data that we obtain are far higher than we can get from any type of self-report method. This is the direction that our current work is going in. We're actually looking at this point to try to convince people in Australia at least, and maybe some people here in the US as I go through giving seminars like this, that it's about time now for us to experiment with replacing a paper household travel survey with a GPS survey. Thank you. Yes.
So I'll start out the questions, and
Yes.
I'll remind people to use the microphones when you ask the questions. We've already had some questions come in from our web viewers, and one of those is actually a question I had. And so how are you distinguishing the different modes? I imagine speed is part of that, but I'm particularly interested in the bike mode, because I can imagine a bike might travel about the same speed as some other modes. Or talk about that a little.
We actually use a hierarchical method. We start out by identifying walking, which is the most obvious one because of speed and acceleration, deceleration. And we use those characteristics. We use the speed and acceleration, deceleration. We also look at the route that is used. So walking is pretty easy because usually it's the slowest mode and it has the lowest acceleration and deceleration rates. The next thing we do is we pick out and identify the off-road public transport modes, such as rail, ferry in our case. Those are also very easy because they actually track along the routes of those modes. What you're left with at that point is probably bus, bicycle, and car. Now, bus gets to be fairly easy because we have all of the bus routes in a GIS, and we also have the location of bus stops on a GIS. So if a trip, say, and by the way, when we do our trip identification, it actually identifies as a trip each trip by one mode. So if you use a walk to a bus stop, then you ride a bus, then you get off the bus and you walk to your final destination, that's going to be identified as 3 trips. Okay? So if we have a walk at the beginning, a walk at the end, and a bus stop as the destination of one walk and the origin of the next walk, and in between it runs entirely on a bus route, it's a bus. So that gets the buses. And usually another thing that we're now finding we're able to do is that our devices are sufficiently sensitive that they're picking up each bus stop. So if the vehicle keeps stopping again, and it stops where the GIS location of bus stops is, we're pretty sure that this is a bus. Bicycle usually comes next, and we get that again by speed and acceleration, deceleration. We do have the situation that in Sydney we've got some pretty steep hills, and so if you're going downhill, you can actually rival a car in both speed and acceleration, but you can't when you go uphill. And so we generally pick it up. One thing I should mention here is that when we look at speeds and accelerations, we use the 85th percentile value for the maximum, because using GPS you're going to get occasional readings that are ridiculous because of simply the way in which the position will waver around sometimes. And your imputed acceleration, deceleration can be, for less than 1 second, it can be very high. If you take an 85th percentile, you get rid of all of those aberrations that come about from the GPS measurement. And so by the time, and also we use one other thing with the bicycle. I mentioned earlier that one of the things we collect in our household information is whether or not the household owns any bicycles. If you don't own a bicycle, then you are not eligible to have a bicycle mode. The other thing is we also look at the origin and destination of the trip. If your origin is not home, and we think this trip is bicycle, then you must have used bicycle on a previous trip to that location. So once you put all of that logic together, and I'm glad I don't have to do the programming for this, but I've got a good programming person who does it. Once you put all that logic together, you get a pretty good identification of node.
So then you want to explain trip purpose. I mean,
Okay.
You collected the work and the shopping address
Yes.
and the school address, but beyond those...
Well, and you've got home, of course, because since we either are delivering these or we're knocking on the door, we know the home address. The other thing that we have, and I don't know how much this exists yet in the US, but it's actually becoming very common in Australia, we have a parcel-based GIS, which gives us the land use of every parcel. And so what we do is then, after we've dealt with ones like the home, work, school, shop, then what we do is we look at the land use. And we also look at how long the person spends there and how often they go there in the period of time that we have been collecting the data. And we have a set of heuristics that we've developed that allow us then to identify the purpose. Now, if you are trying to identify purposes down to a very fine level of detail of perhaps 12, 15, 20 purposes, I would have to say we're not doing a very good job. If you're looking at only 3, which an awful lot of transportation studies have used only 3 for modeling purposes, which are usually home-based work, home-based other, and non-home-based, or maybe 4 if you split non-home-based into other work and other. And even if you want to split out home-based education or home-based school from the home-based other, we can do all of those very well indeed. In fact, we're probably at better than 95% accuracy on the purpose. So it's really a matter of what level of aggregation you want on your trip purposes. And this is, I would say, a work in progress. We're still refining our procedures for this, but it's already working pretty well. We're at a fairly coarse level of purpose definition. We think that we're probably doing better than 95%. Yes?
First of all, thank you very much for your great presentation. 2 years ago, under the Oregon Modeling the committee, we studied the Cosmo project, which is exactly we want to identify what GPS's survey status is and where we're heading to. And that study actually, from that presentation, I had an impression we're a little far from the implication to use it in our survey because of the cost was quite high and the this passive way of capturing, people forgot things quite a lot. So didn't have a good feeling we're going to succeed next to our survey with the GPS in terms of, but actually today presentation really changed my attitude and understanding what's going on in the latest event, and it's really, really great. I had a couple questions for you. One is, this sampling size you're talking about household is pretty small to me. And I have a question. These days, everybody, everywhere want to understand who you are, why you're doing certain behavior based on your lifestyle and accessibility. And with this given your sample, although, yes, with the GPS we have a tremendous amount of information, but those peoples are fixed in a way that are limited, that cells. So if you want to understand 4 by 4 by 4 by like a household size, number of workers, and the number of cars, and the income group by different segment of the geographic location, which is very good accessibility by transit walk or even somebody using ferry, then how you control the sample within the only few thousand of millions, people. And at the same time, how you're going to aggregate, understand their movement by more aggregate geography, east to west to west-east, various districts you're talking about when you aggregate. So I just don't get ourselves to be that small sample and telling them we can understand everybody's lifestyle here.
I don't think that we would ever understand everybody's lifestyle, whether we do this with one-day surveys or GPS surveys or whatever. Clearly what you're describing, though, is a very specific requirement that you have in your data collection. And the way I would go about that is I would go for a stratified sampling technique where I'm going to look for people who fall into particular categories that I am most interested in knowing information about. And that's what I would use to control my sample. So I wouldn't be looking for a broad, random sample. I would instead be looking to try to find people who fit the different types of subgroupings that I'm most interested in measuring. That's still going to generate a larger sample size, certainly, than what I was talking about here, but it would generate a much, much larger sample size if you were using a conventional one-day survey without the wealth of information that you'll get. You'll still be able to use a much smaller sample because you can start looking at this as person days of data is actually the unit that you're collecting information on, with some modification in the variance that's based on the intrapersonal variability component. So I think it can be done. I'm also, by the way, a big believer in panel surveys. I think that actually in the transport profession, we've failed to make good use of panels. I mean, your neighboring large city up in the next state pioneered one of the only transport panels that's ever been undertaken, the Puget Sound transportation panel. I don't think we've used panels anything like the way we should have done in transport. I think that actually tracking the way that people's behavior changes as their circumstances change, as the transport system changes, would actually reveal to us a great deal more and may well reduce the needs that we have for more broad-based data. And I think that's a direction that we need to pursue much more actively. Yeah.
So we have a few more questions on the web. I'll throw out one of them before we go back to in-house. And that's questions about privacy. And obviously people participating have agreed to participate and understand. But have privacy issues come up? And the question that came on the web, particularly if you might want to speculate if that would be a bigger problem in the U.S. compared to Australia, or do you have any sense of that?
We have a sense of the extent to which it is an issue in Australia, and that is very small. In trying to find out from people who refused to take the GPS the reasons that they refused, we only find that concerns about privacy come up about 5% of the time. People in our focus groups said it wasn't an issue. Now, of course, these are people who agreed to do it. And so there may be a difference here between people who agree to do it and people who don't. But basically our findings have been so far that people don't seem to see privacy as a big issue. Perhaps partly because they don't have a way of seeing what it is that we're going to know about their travel by us giving them this little black box to carry around, because it doesn't display anything. And even though we have actually sent out a newsletter to participants to show them some of the sorts of traces that we have of people's travel, it still doesn't seem to raise privacy issues or concerns in their minds. Now, another thing that may be helping us here is the fact that we're logging the data, we're not collecting it in real time, and by the time we get the device back and we download the data, the behavior that we've been looking at is past history. And I think that a lot of people are intelligent enough to realize that, and that what it reveals is not something that they're very concerned about.
And if they're going somewhere embarrassing, they can always say, oops, I forgot to bring
Exactly.
a device.
Exactly.
Yeah, I have two questions. One is sort of around the real-time issue. Is seems like we can do a lot of this with the cell phones now in terms of the data capture, and that it could be more real-time, or it could be much more interactive with people even to pick things up, or variances, or reminders, or other things. That's question one. Second question is, you did a lot with your diaries in terms of nailing down where they work, shop, typical locations, but what about asking them to fill out a typical pattern? And then if you were getting the data in real time, you could see where those variances occurred from what they intended to do in a day versus what they actually do in a day. And maybe that reduces some of the variance between and the time of that 2 weeks. So just curious your thoughts on that.
So far as the use of the real-time data collection aspect, one of the reasons I guess that we have not pursued this in Australia is that our telephone companies at the moment see data transmission in real time as a big cash cow. The result is that they charge us ridiculously high rates, and so we don't even look at it for economic reasons. We haven't used the cell phone itself because the accuracy of the cell phone in terms of tracking position is still far poorer than what we can get from this. The rated accuracy of this device is a positioning of about plus or minus 7 meters, but we find in practice it's about plus or minus 3. From a cell phone in a downtown area, you'll get about plus or minus 40 meters, and outside of the downtown, at plus or minus 100 meters, which doesn't even tell you which street they're on. So we have not been particularly interested in pursuing that. We also feel that for what we do, the real-time aspect doesn't have sufficient advantages to make it worth our while to pursue it. Now, that may change over time, but at the moment we don't find that there's a compelling argument to look at the real-time data collection. And it may, as we just talked about, raise some much bigger privacy issues and give us a much bigger problem in terms of people's willingness to participate. Now, the second part of your question, or your second question, I'm blanking for a moment as to what you asked.
About filling in the pattern.
Oh, yes. Again, I think one of the things that would do, I don't know how people would tell you what a typical pattern is, because people typically don't do the same thing day after day. But what you're also doing is increasing the burden again. What we're trying to do is we're trying to move to a way of collecting data that involves almost no actual effort on the part of the respondent, in the belief that in this day and age, people are very resentful of anything that burdens them. However, along the lines of what you're talking about, there is some very interesting work going on in Canada. Sean Doherty is the person pursuing it for the most part, looking at how people's plans for their travel actually change and what the actual travel is that they do in the end. So if you're particularly interested in that aspect, We're not doing that research, but Sean Doherty is doing it, and you ought to take a look at some of the work that he's been doing. Lots of questions over here.
Kind of going along the lines of participation burden, what kind of difference have you noticed between the large packs to just the small things? Have you noticed more people willing to participate once they realize that it's just this small thing as opposed
Yes.
to a large pack on their size?
That made quite a big difference. The size and the weight, the ease of carrying this around has made a huge difference in the response rates. In fact, we really haven't deployed this one yet. We're still waiting. This is a prototype that I'm carrying around at the moment. I had actually expected that our first order of 100 of these was going to arrive while I've been traveling. It's actually been delayed and isn't going to arrive until next Tuesday or Wednesday. And that's when we're going to actually start putting that one into use out in the population. But from what we've seen so far, I am expecting that this is going to actually generate a significant improvement in the response rate. And yes, it was definitely lower with the bag over on the shoulder and the big battery pack and so forth than what we experienced with our second generation device. Let's see over here.
I wonder if you could speak to what the results have shown in some of these long-term studies, like the one in Adelaide with TravelSmart, in terms of persistence in the desired change in behavior.
We can't tell you that yet. The reason being that the TravelSmart intervention was actually rolled out over a period of a year, which ended at the end of last year. We are about to do our third wave of GPS measurement in September of this year, and until we get the data in from that, we actually won't know very much about what the longer-term implications are from it. Some of our preliminary evidence suggested somewhere in the region of about an 8 to 10% reduction in vehicle kilometers of travel. But that was very preliminary, and I wouldn't like to hang my hat on that at this point. Yes?
Two questions. The first one is, have you used the GPS as supplement to a traditional 1 or 2 day activity survey? And the second question is, have you guys actually estimated a travel model using just the GPS survey data?
On the first question, not really. What we did when we were first using the GPS devices about 6 years ago, we used to do what we called a prompted recall survey, in which what we did was to produce the maps similar to some that I showed you with that table, and we would then send those back to the participants and say, what were you doing on each of these trips, and who were you traveling with, and what mode of travel were you using, and so on. So while we weren't collecting a diary while they were doing it, after the fact we asked them if they could tell us what they were doing. We got good results from that, but it's a very, very labor-intensive task. It's quite burdensome, and we found that it was simply adding an unacceptable level of cost to the survey, and that's why we've abandoned it. I still like the method myself, but it just costs us too much to do. And your second question was whether we've actually used the data for any modeling yet, and the answer is no. But watch this space, because it's going to happen within the next 12 months. Yes, Risha.
I had a question about your findings on the variance, very interesting graphs. I was just wondering if those findings were consistent across cities, or was that just data from a single place, and would you expect the same findings in Australia as in the US?
So far, those results are only from one location. It's all from Adelaide. But I have no reason to suspect that this is something that's specific to Adelaide. So I would expect that we will get similar results as we broaden this out and collect data in other locations. And yes, I think I would expect to see the same thing here in the US as we found in Australia. In a lot of respects, and certainly relating to travel, Australians are much more similar to Americans than you might expect. They are equally much, if not more, in love with their cars than Americans. And they travel probably as much or more than the average American. Yeah.
3 short questions, actually. Who's manufacturing the new device? And also, is there competition between different manufacturers, and are they available to us here in the United States?
These devices are being manufactured in Taiwan. If you want to acquire these devices, the best thing to do is to contact me. We've been working with our supplier, who's actually in Western Australia, and we've come to a decision at the moment that the University of Sydney will on-sell these devices to anybody who's interested in purchasing them. Is there competition? Not really. This device has actually been customized to our specifications, and so I don't think there's any other device like this anywhere in the world at this point. We actually went on a search on the internet to try to find a device, a logging device, that would do what we wanted. We couldn't find one that did exactly what we wanted, but we found one that was actually the forerunner of this, and then we contacted the supplier in Western Australia and said, look, this is what we're really looking for, and this is what you've got. Is there any possibility that you can find somebody who would make this for us? And they got on to the manufacturers in Taiwan that make this device and asked them if they would be willing to customize it, and they said yes, they would. And they've been customizing this device. They changed the chipset in it. They've added more memory to it. They've changed a couple of other features in it, and all of these to our specifications. And the latest thing is I got a quote. There is a small additional cost for having a charger that will plug into the US electricity system as opposed to the Australian one, because Australia, like the UK and a few other places around the world, has a 240-volt 50 hertz system compared to the 110 60 hertz system here. So we are now in the process of actually acquiring some chargers for these that will work here in the US. Also, by the way, it plugs in with just a USB cable, and it also will plug into an in-car socket so that you can actually charge it while you're driving your car. Yes.
Well, we're actually at 1:30, so
Okay.
I'm going to have to cut things off, unfortunately. I want to thank you before we thank you again, I do want to put in our plug for next week. We have 2 of our own graduate students who are going to be talking about the research they've been doing for their field area projects, one on bicycle and pedestrian overcrossings and another on car sharing payment integration, so we hope to see some of you there. Thank you again very much for a great presentation.